Alice, Bob, and Eve explain tensor networks.
I'm trying to solve this complex math problem by breaking it into smaller linked pieces. There are just too many variables to handle all at once.
What you're creating there is remarkably similar to tensor networks in quantum computing.
Tensor networks are such an elegant approach. They're mathematical tools that help us work with complex quantum systems that would otherwise be impossible to simulate.
How do my sticky notes relate to quantum computing?
In quantum mechanics, describing many interacting particles requires tensors, mathematical objects that can have many indices or dimensions. The complexity grows exponentially with each particle you add.
Each of your notes could represent a tensor, a collection of numbers arranged in a specific pattern. The connections between them show how these tensors relate to each other.
So tensor networks are about breaking down massive calculations?
Exactly. Instead of working with one enormous tensor that might require more memory than exists in the universe, we factorize it into a network of smaller, manageable tensors.
The simplest tensor network is a matrix product state, or MPS. It's like arranging your notes in a chain, where each connects only to its neighbors.
My arrangement isn't just a line, though.
There are many types of tensor networks with different structures. PEPs, projected entangled pair states, are arranged in a 2D grid. Tree tensor networks branch out like trees. MERA, multi-scale entanglement renormalization, ansatz, has a hierarchical structure.
The key insight is that many quantum systems, especially those with limited entanglement, can be efficiently represented this way. Not all connections between all parts are equally important.
How does this help with quantum computing?
Tensor networks let us simulate quantum systems that would be impossible to model directly. They're used to design and analyze quantum algorithms, study quantum materials, and even understand quantum error correction.
It's like how you can fold this paper to connect distant points directly instead of traveling across the whole sheet. Tensor networks find efficient ways to represent quantum information by capturing the essential structure.
Do quantum computers use tensor networks in their operation?
Not directly in their operation, but tensor networks are powerful tools for classically simulating and understanding quantum systems. They help us bridge the gap between classical and quantum computing.
They're also inspiring new quantum algorithms and providing insights into quantum machine learning.
So my whiteboard problem-solving method is like what quantum physicists do, finding clever ways to break down enormously complex problems into interconnected but manageable pieces.
Precisely. And just as your sticky note network captures the essential relationships in your problem, tensor networks capture the fundamental structure of quantum states without getting lost in the exponential complexity.
The most beautiful thing about tensor networks is how they reveal the underlying patterns in quantum systems that would otherwise be hidden in a sea of numbers.